Hello, my name is Alex Carver. I'm a Senior Solutions Engineer with Pure Storage, primarily focusing on VMware products and our integrations with them. Continuing on with the vVols 101, let's go ahead and dig into what exactly a protocol endpoint is. Now, a protocol endpoint is unique to the vVols architecture in that it's not used outside of vVols. Now, recall that when you have a VM that is running vVols, it actually has objects, volumes directly on the array associated with them. So, you would have a config vVol, a data vVol correlating to the virtual disk for this VM, and when the VM's powered on, a swap vVol. Now these volumes, if they were connected to the ESXi host for that VM in a traditional manner, that would be 3 volumes just for the single VM. Now if you start scaling that out, hundreds or thousands of VMs on a single host, potentially dozens of virtual disks, which correlate to at least a dozen volumes on the array for each one of those VMs. And you could quickly get to this point where you're running out of the number of maximum amount of paths available on that ESXi host or the amount of available LUNs. And so you start to hit these limits within the ESXi if it was connected like a VMFS data store or an RDM. And so VMware approached this in that, okay, we need to solve this problem if we're going to have granular objects at a storage level for each one of these VMs. So they incorporated the concept of a protocol endpoint. When you have an ESXi host, it needs to be able to connect to each of these volumes when this vVol VM is actually on it and powered on. And so rather than needing to connect to each volume individually, this host would be connected to that protocol endpoint, the PE. The pathing would be managed at that PE level. So you would set up your native multipathing on the protocol endpoint, and that's all you would need to worry about. Now all the multipathing would be inherited when these vVols are now connected or bound through the PE to that ESXi host. Now these become what are called sub-LUNs, or subsidiary LUNs. And the PE would be an administrative LUN. And this is for the kind of SCSI spec terms for it. Is a subsidiary LUN correlates to the vVols, and then the administrative LUN correlates to that protocol endpoint. The way this would look is if you had that protocol endpoint connected to the ESXi host, say LUN 254. Well, when ESXi issues a bind request to the VASA provider, it's wanting to connect the vVol to that host. And so it would connect through the protocol endpoint, and it would look something like 254:1. And then when it connects the data vVol, it would look something like 254:2. And when the swap's created and connected, it would look something like 254:3. Now these numbers could be different depending on which actual LUN number is available for them, but these sub-LUN connections through the PE to the ESXi host, they don't add more paths. They don't add more LUN numbers being connected to the ESXi host. From a standpoint of what the limits are, it's just a single PE, and the paths to that PE are counted, and then all the other ones just inherit what the settings are on the PE, from both a QDEP setting and from a paths number. So this helps address the scale problem that you would have had if you were connected like traditional VMFS or RDMs, and still being able to have the simplicity of, I only need to connect the PE, that's the first thing I do. Now I don't have to worry about actually doing any volume disconnects, reconnects, connects, rescans, and that whole business. And so it helps simplify the automation of these volume creations, connections, disconnections, etc.